Bezos or Musk? Who is right about space?
Jeff Bezos and Elon Musk, two men with the greatest economic resources, agree on one thing: humanity belongs in space, but they disagree on how we should get there. One of these visions is likely to shape humanity's future, and in this video, I'll explain why.
Space colonization. Visions of Bezos and Musk. Bezos' vision is humans living in space habitations, the sort first popularized by Gerard O'Neill in his seminal work, The High Frontier: Human Colonies in Space. We envision a future where millions of people will live and work in space to restore and sustain Earth. This is the official long-term vision statement of Blue Origin. I would love to see 1 trillion humans living in the solar system, Bezos said in a 2023 interview, arguing that space resources could support enormous human populations. With 1 trillion humans, we would have 1,000 Mozarts and 1,000 Einsteins. A vastly larger civilization would produce vastly more genius, creativity, and innovation. Musk, on the other hand, wants to make humanity a multiplanetary species. I think there is a strong humanitarian argument for making life multiplanetary. Musk frequently argues that civilization should not keep all of humanity on one planet. Either we spread Earth to other planets, or we risk extinction. Musk argues that humanity faces existential risks if it remains confined to Earth. Eventually, there will be thousands of starships going to Mars. Musk envisions mass migration using reusable spacecrafts.
Roadmap for the rest of the video.
Space habitations. Closed ecosystems and nitrogen-efficient space habitations. Humans as a multiplanetary species. Bezos or Musk? The answer: Enlightened Culture. Proper sequence of space activities. Real versus fleeting sustainability. The Millennium Space Science Challenge. Win up to $7,500. Space habitations. A concentric spinning tubes space habitation. Cross-sectional view. The different parts of a space habitation, such as agricultural and habitation zones, residences, offices, parks, lakes, hiking trails, sports facilities, etc. The important physical necessities for a space habitation: gravity, agriculture, protection from radiation, and the physical necessities for luxurious lives. As humans who make their homes in space will be leaving behind the beautiful Earth with its blue sky, an effort must be made to provide them with material goods and services for a luxurious life. Videos of life in the space habitations. The space habitations should have luxurious lives for the inhabitants far exceeding that available to the average person on Earth. This includes not only the houses they will live in, but also other requirements for an interesting life, such as parks, lakes, playing fields, hiking and biking trails. restaurants, theaters, etc.
All the amenities we have on Earth and more will be there in space. This will be possible as the resources available in space far exceed those of Earth. Given the four main requirements, an appropriate design for a space habitation is a multi-layered spinning tube. The design presented in my book, Humanity's Next 1,000 Years, has similarities to the O'Neill cylinder, which in turn is a successor to the Bernal sphere. But my design also has many important differences. Can space habitations really be so large as to have casinos, swimming pools, golf courses, nature reserves, deep lakes with varied marine life, carnivals, boat races, etc.? Yes. The calculations in my book show that there is enough mass in space to build gigantic space habitations with these. As Musk said, physics is the law. Everything else is a recommendation. It took only 66 years to get from the Wright Flyer to the Boeing 747, and 12 more years to the Space Shuttle. Only 75 years from Maniac to the iPhone 17, which weighs about 2,600 times less and can perform 100 million x more operations per second. Space habitations built in the future, mainly by robots, will be similarly amazing compared to what we currently have. Based on the calculations in my book, a sample space habitation for 50,000 humans will have a mass of 1.37 trillion kilograms, a diameter of 1.6 kilometers, a length of 11.3 kilometers, and a rotational speed of 1.26 revolutions per minute for an Earth-like gravity. This can be easily scaled up 10 times, or even 100 times. Construction by robots in zero gravity will be completely different from construction on Earth, and orders of magnitude larger structures will be built.
Space habitations docked on a ring around the Sun. In the later stages of the colonization of our solar system, the space habitations will be docked to a flexible ring around the Sun, with an electromagnetic rail for transport. This will allow for the transport of humans and materials between the space habitations without any mass being lost as rocket eject. The Sun will enable life in our solar system for a few billion years, so using up mass as rocket eject to maintain orientation and for transport is not a good solution. Closed ecosystems and nitrogen-efficient space habitations. Is a closed ecosystem in space really feasible? Yes. The Melissa Microecological Life Support System Alternative Life Support Project is a closed ecosystem with a pilot plant located in Universitat Autònoma de Barcelona. It is a bioregenerative life support system designed by the European Space Agency for the complete recycling of gas, liquid, and solid wastes. An interesting question. What sets the limit on the sustainable carrying capacity of our solar system, excluding gas giants and the Sun, and likely other solar systems for humans? Is it elements needed for construction such as iron, aluminum, etc.? No. Is it carbon, with its 4 arms, that enable the building of the complex molecules needed for life? No. Is it oxygen, without which we would suffocate? Still no. It is actually the somewhat inert, humble nitrogen. A 70 kilograms human body has about 2 kilograms of nitrogen. Now, conservative estimates for the amount of accessible nitrogen in our solar system, largely from Earth and Titan, and also Venus, the Kuiper Belt, Pluto and Triton, is about 10 to the power 20 kilograms. So it would appear that our solar system has enough for 10 to the power 19 humans, or even more. However, in a simple design of a space habitation, with air at 1 atmospheric pressure and 78% nitrogen leads to 435,000 kilograms of nitrogen required per inhabitant. So, the nitrogen requirement in an unmodified space habitation is about 435,000 kilograms, and not 2 kilograms per inhabitant. There are two nitrogen-efficient strategies for reducing the nitrogen requirement. The first is changing the mix of the air inside the space habitation to 20% nitrogen, 78% oxygen, and 2% water vapor at approximately 0.27 atmospheric. Fire risk should be manageable with this mixture of gases, but something to keep our eye on. The next strategy is a design modification of the space habitation. The length of the cylindrical habitation is 11.30 kilometers. The inner living habitation zone with houses has a ceiling 10 meters and is broken into 10 residential sections of length 800 meters each. The remaining 3.3 kilometers is divided into 11 recreational sections of ceiling height 30 meters each. The ceilings, clear glass films, create enclosed cans filled with pure oxygen at a slightly higher pressure compared to the residential and recreational areas. Compared with the earlier 435,000 kilograms per inhabitant, the nitrogen efficiency strategies will decrease nitrogen requirement by 99.56% to 1,880 kg per inhabitant, and correspondingly increase the sustainable carrying capacity of space by a factor of 230.
Due to my nitrogen-efficient strategies, there will, in the future, be more than 5,000 trillion additional humans living in our solar system than would otherwise have been possible. This is one of my 7 major works for the benefit of humanity, some completed and others still in progress. My other works are the Enlightened Culture, Making Our Personalities and Lives Immortal, The Nature of Reality, Improving Mental Health and Happiness, Ending Wars, and Reversing the Demographic Bust.
Humans as a multi-planetary species. We have spent quite a bit of time discussing space habitations. Let us consider the alternative: humanity as a multi-planetary species.
The most obvious candidates for human habitations on celestial bodies are Mars and the Moon. Over time, humanity will colonize other solar systems. But as I show in my book, the time taken for a scientifically feasible multi-generational colonizing vessel to reach our nearest neighbor, the Alpha Centauri star system, is around 10,000 years.
It will happen, but not immediately. 10,000 years may seem a lot, but our sun will give humanity a few billion years in our solar system if it can get over the stupid wars that we are addicted to. 10,000 years is a trifling amount of time. There are some obvious advantages to building habitations on the surface of celestial bodies. Uno, familiarity. We are used to living on the surface of Earth rather than inside a cylinder, though admittedly very large. Dos, speed. We just need to build the habitations on the surface rather than constructing the gigantic space habitations, which will also pose a set of additional engineering challenges. Bezos or Musk? The answer: so will we live on the surface of other celestial bodies, or inside giant spinning space habitations. An important consideration is sustainable carrying capacity. A generous estimate of the sustainable carrying capacity of Mars is roughly equal to Earth's current population, while that of the Moon is around 20% of Earth's, for a combined total of approximately 10 billion humans. What about space habitations? According to the calculations in my book, also briefly covered later in this video, if we were to just use materials from Mars with nitrogen from Titan, we could build space habitations with a sustainable carrying capacity of more than 2,000 trillion. Yes, that is trillion, not million or even billion. For the entire solar system, it is 5,300 trillion. Bezos or Musk? Who has the right idea about space? We are ready for the answer. 10 billion versus 5,300 trillion. That's an easy choice. Also, space habitations will provide luxurious living with controlled weather rather than the harsh environment of Mars. Have Earth-like and not Mars-like gravity. Abundant radiation shielding without having to live under a heavy roof like we would have to on Mars. So humanity will live in space habitations rather than on the surface of celestial bodies. Bezos is on to something good. Yes, space habitations will likely take longer to construct and require more new technology. But good things require more effort. That should not be surprising. Musk also has something very important to say. The absolute necessity of reversing the demographic bust that communities the world over are experiencing. The reality is that if the demographic bust is not reversed, then humans will not colonize space, simply because there will be no need for resources beyond those of Earth. Enlightened culture. Of course, we do not want a growing human population in which some oppress others. We want space habitations to have enlightened culture. I define enlightened culture as the set of norms, beliefs, and goals that 1. For the individual and the community, leads to strong bonds of love among family members and engenders strong friendships and communities. 2. For the individual, stresses fulfillment of duty, loyalty to family and friends, honesty, good manners, work ethic, and other virtues, along with sensory and other pleasures. 3. For the society and the community, offers its members the opportunity for the best possible life, which includes healthy relationships, achievement, attractive economic opportunities, fulfillment of duty, honesty, adventure, personal freedoms, sensory pleasures, etc. 4. For the society and the community, includes egalitarian laws that provide stability, as they have the support of a large majority of the population and good manners that facilitate healthy social interactions. 5. For the society and the community, balances greater equality of economic and political power with the requirements of efficient functioning. 6. For the individual and the community, includes policies to assure the maximum well-being of the present and future generations, comprehensive utilitarianism, stable culture, and the grande procalpo. 7. For the individual and the community, is considerate to all humans, is not aggressive towards other societies and communities and helps them when possible, but effectively resists aggression by other societies and communities. 8. for the individual and the community, strikes a balance between being kind to animals and their use. Proper sequence of space activities. Since the first person traveled to space in 1961, there have been many technological achievements, such as Mercury Redstone, Salute, Apollo moon landings, Voyager flybys of planets, Space Shuttle, Mir, International Space Station, Venera, Mars 2 and 3, Mariner, Viking, Maven, Mangalyaan, Hope, Tianwen, and other missions to Mars, the reusable rockets developed by SpaceX, etc. The question arises, what is the goal? Technological demonstrations are commendable, but how do they advance humans' journey to the big prize? Human space colonization? Rather than investing money in a haphazard fashion on technology demonstrations, money should be invested to advance human space colonization, the first step of which will be the construction of space habitations. This will require 1. Technology and machinery for the acquisition of raw materials and energy, primarily solar panels, in space. Only the initial raw materials for the machinery will be shipped from Earth. The bulk will be acquired by mining celestial bodies. 2. Technology for manufacturing infrastructure capable of self-replication in space. 3. Design of a space habitation, including a complete closed ecosystem capable of supporting human life, which includes modified plants suitable for being grown in space habitations. Instead of an unsynchronized investment of resources, space programs should work together to achieve the above goals by following a coherent and comprehensive plan. Real versus fleeting sustainability. At the end of this video, let me make a brief comment about real sustainability that we can have in space, and only fleeting sustainability that is possible on Earth. At its core, sustainability is providing physical and cultural resources required for a good life to the youth and future generations. The only real sustainability is in space. On Earth, we can only have fleeting sustainability. Space offers many orders of magnitude larger physical resources for human habitation compared to Earth. Humanity's present economic trajectory on Earth and the concomitant pollution will lead to failure in a few hundred, or at most a few thousand years. For example, multiple researchers have noted the heavy metal poisoning of Earth's ecosystem due to industrialization. In contrast, due to an abundance of energy, the ecosystems of space habitations can be rebooted as many times as we wish. Sustainability may be real sustainability or fleeting sustainability. If we provide future generations only a tiny fraction of the resources that it is possible for us to provide them, and which will last them at most for a few thousand years, then we would have what I call fleeting sustainability, an oxymoron. It is illogical to say we should care about Earth's environment, which has a carrying capacity of around 7.9 billion humans, but be indifferent to colonizing space, which has a carrying capacity of 5 million billion, just our galaxy, and even more if we colonize other galaxies. This is an illogical position based on a failure to understand the possibilities that advancements in science offer. The Millennium Space Science Challenge. Win up to $7,500. Next, I want to tell you about the Millennium Space Science Challenge. I believe space is very important to humanity's future. To truly harness the nearly infinite resources of space, we must have an accurate understanding of the scientific issues involved. The goal of the Millennium Space Science Challenge is to increase the general public's awareness of the scientifically consistent possibilities that space offers humanity. Here are the abbreviated versions of the 5 challenge topics with current ChatGPT ratings of the science. These are based on analysis done in my book, The Greatest Book for Humanity's Greatest Project. 1. The sustainable carrying capacity of Mars converted to space habitations for luxurious living is 10 trillion humans, or more within one order of magnitude. Rating 9 out of 10. 2. The sustainable carrying capacity of our solar system for luxurious living is 1,000 trillion humans, or more within one order of magnitude. The sustainable carrying capacity of our galaxy for luxurious living is 5 million billion humans, or more within one order of magnitude. Rating 9 out of 10. 3. The value of Earth converted to space habitations is $1 billion or more for every current human on Earth, assuming the average value of land in the space habitations will be the same as the current average value of land on Earth, within one order of magnitude. Rating 9 out of 10. 4. A multi-generational colonizing vessel from one star to another, for example, from the Earth to Alpha Centauri, is scientifically feasible. Rating 8.5 out of 10. 5. In large-scale space habitation systems, the finite availability of mass, especially key elements, will constrain sustainable carrying capacity before energy availability becomes limiting, because usable energy can be expanded more easily than mass. Rating 9 to 9.5 out of 10, this claim essentially says that the idea behind the Kardashev scale is wrong. I am so sure that the above claims are strong that I am willing to offer a reward for whoever proves me wrong.
Reduce the scientific validity of the 5 claims listed above to a ChatGPT rating of 2 out of 10, and you will win $1,000 for each claim refuted. Unless someone else has already done so before, and the contest is still open. If you are the first to refute all 5 claims, you will get a bonus of $1,000 for a total of $6,000. If you are a high school or an undergraduate student, you will get a 25% bonus, a maximum of $7,500.
You can start with my ChatGPT analysis and then provide your own prompts. Your ChatGPT prompts must be based on known laws of physics and meet certain other requirements. No purchase necessary, though reading the book will give you the design details of the space habitations, the interstellar colonizing vessel, etc., that form the basis of these claims. Details and rules are at this URL.
More videos on my channel. Design of an interstellar colonizing vessel. Project Hail Mary. Hard science, or hardly science. The optimal economic system. What is and is not science? Whoever follows my plan will win the 2028 presidential election. And beyond? Entropy, free energy, complexity, time required, and error rate for construction. Add 3 healthy years to your life. The alien colonization threat. The persistence of life in an entropic universe. You are very, very, very special. Your life is a miracle.